Okay, so today what we're doing is derivatives of trig inverse trig. We've done derivatives of trig functions, right? The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. The derivative of cosecant, let's see, it's on your sheets. Derivative of cosecant is negative cosecant cotangent. Derivative of secant is secant tangent, and derivative of cotangent is negative cosecant squared, right? We did those several weeks ago. Well, now we have inverse functions. So my question is, what's the difference between a trig function and an inverse trig function? What's the difference? Obviously that word inverse, but what does that word mean, inverse? So here's a question. When we did inverse functions last Friday, what was the difference between inverse functions, original function and its inverse? What was the difference? What did we change? There's one thing we changed. The x and the y, right? The x and the y swapped places, right? So here's my question. For inverse trig, something has to swap. Something does swap. What is it? Does anyone know what swaps for inverse trig? Well, here I'll give you an example. The sine, a sine at pi over 2. Sine at pi over 2 is 1. It's on your sheets. It's true. Sine of pi over 2 is 1. That's what a normal trig question asks. So what does a inverse trig ask? Inverse trig swaps these two. Swaps places, right? Well, what swaps places? This guy and this guy, right? So in other words, we can call this guy x and this guy y. So what inverse sine or inverse trig does is they switch x and y again. So it looks like this. You still have that little symbol here, still have that little inverse symbol to tell us that we're not finding sine, not finding inverse sine. And then this number here is not an angle. This number here is an angle, 90 degrees, right? Sine at 90 degrees is positive 1. Well, what is inverse sine of 1? What do you think the answer is going to be? 90 degrees. Or pi over 2, yeah. They just ask a different question. They swap values. That's all it is. This guy is asking, what is the ratio at that angle? What is the sine ratio? Y over 1 or y, or just y, right? For sine, that's sine's ratio. What is the ratio at that angle? So you go, okay, let's see, the unit circle, 90 degrees is there. So that's 0, 1. So if it's y over 1, y is 1. So it'd be 1 over 1, which is 1. Okay. Inverse sine says, okay, I'll give you the answer. Tell me the question. I'll give you this part here. You tell me where you were. So if you're at 1, if your answer is 1, where are you at? What's the problem with that, though? Look on your pink sheets. What's the problem with that question? If the answer is 1, where are you at? What's the problem with that? You could be at a couple different spots, right? You can be at 2 spots. I could be at pi over 2, or where else could I be? Not pi. Where else is 1? 2 pi. You could be at 2 pi. And the sine curve, the sine wave goes like this, right? And it keeps going. So there's other places I could be forever and ever and ever. So where specifically? Well, that's where we come into this guy here. That's where we come into this guy here. We only want, so inverse sine, you'll see arc, the word arc in here, it's the same thing. So instead of writing the negative, they write arc. It's the same thing, okay? So we only want from here to here. That's the only spot we want. So for sine, for this guy here, we only want our answers to be from negative pi over 2 to positive pi over 2. So those other bigger answers we don't want. So that's why it's just pi over 2. Okay? That's what inverse sine does. Inverse all of these, right? Inverse all of these. They all just say, they switch the question. Okay, if this is your answer, where are you at? That's all they say. Whereas regular sine says, I'm here. What's my ratio? What's my answer if I'm here? Right? That's what regular sine says. Okay, that's the difference between inverse trig and regular trig. They just switch the question. Okay, so again, these are the same thing. So sometimes you'll see the word arc in front. Sometimes you'll see this, which is the symbol we're used to seeing. Right? Same thing. Same thing. Okay. Okay, so just like tangent, or sorry, just like trig, we have derivatives. Derivatives for inverse sine, inverse cosine, inverse tangent, inverse cosecant, inverse secant, inverse cotangent. They're all very, very similar. They all are very, very similar. They all have some form of a derivative on top, right? They all have some form. And what is that derivative of? It's this guy here, whatever this guy is. Whatever this guy is right here. That's what you got to do. So some of them have negatives, three of them have negatives, three of them have positives. Sine, secant, tangent, SST, SST, they all have positives, derivatives on top. And then the C's have the negative on top. All the C's have negatives on top. So if it has a C, it's going to have a negative on top, negative derivative. If it doesn't have a C, it's going to have a positive derivative on top. And then if you look at the bottom, look at these two. Sine and cosine have the exact same thing. Tangent and cotangent have the exact same thing. Secant and cosecant have the exact same thing under here. Okay, so are you memorizing 6 different things? No, they're all very similar. You're memorizing like 2 different things, 3 different things. Okay, and we're going to be using them quite a bit. So the more you use them, the more they become long-term memory stuff. Okay, so again, find the derivative. That's the first thing we have to do. Find the derivative of the stuff. The stuff is this, whatever is here. That goes on top. If it starts with a C, it's negative derivative, so change the sign. If it starts with, doesn't start with a C, then it's just positive derivative on top. And then on bottom, if it's sine or cosine, it's the square root. This is the stuff again. You're just going to square the stuff. All of them square the stuff. You look at all of them square the stuff. Whatever the stuff is that you're finding the cosine arc, the inverse sine or the inverse cosine. Okay. All right. These formulas already have the chain rule built into them. So if we have to use the chain rule, just use the formula. You don't have to use the chain rule separately. They already have the chain rule built into it. Because some of them I'll have, if it's like multiple stuff in here, 3x, 4x, x squared plus 10, something like that, then you would have to use the chain rule. But it's already built into these. That's why I use these instead. Okay. All right, let's go then. Let's look at the first one. You don't have a paper on your desk? Because you should have it already. You should have the paper already. Okay. Okay, so find the inverse. cosine, arc cosine, or inverse cosine. Okay? So what I want you to do is go write down what your paper says to do. Write what your paper says to do. Write what your paper right above you. All you got to do is look up, what does cosine, arc cosine tell you to do? Write that down. That's kind of our roadmap or our directions for what we're supposed to do. Okay? Okay, so looking at what we just did, you should have this written down. This is what we got to do. That's our directions. Okay? So negative square root, or negative root, not negative root, negative derivative on top. Negative derivative on top of the stuff. Well, the stuff is in parentheses. The stuff will most all the time be in parentheses. The only time they won't have it in parentheses if it's just x. Sometimes they won't. Okay, so negative derivative of that. Well, let me find the positive derivative. What's the positive derivative? What's the regular derivative of the stuff? 2x. Well, what's the negative derivative of the stuff then? Negative 2x. Yep. Okay, that's the first part. Then on bottom, we have square root 1 minus stuff squared. Okay. Square root 1 minus stuff squared. Well, what is that stuff? X squared. Okay. So we have negative 2x. X squared squared is x to the fourth. Square root. We're done. Okay. Let's look at the next one. First thing I do is highlight, underline, circle, box, parentheses, the stuff, because that's the thing I'm going to be using a lot. Okay? Well, the first thing I got to do is rewrite it. Anytime I'm finding derivative, I don't like roots. Roots don't help me find derivative. So write it like we normally would. Sine, inverse sine, instead of 2x, it's going to be 2x to the 1/2 power. That's the stuff. Okay. Go to the top. What do our directions say? Well, for inverse sine, it says derivative of the stuff. Okay. Well, if I have to find the derivative of the stuff, I'm going to use the chain rule. So I use 1/2 2x negative 1/2 times 2. Or just 1 over square root of 2x. That's really what it breaks down to. Okay? That goes on top. Okay? On bottom, inverse sine says same thing as cosine. 1 square root of 1 minus stuff squared. Square root 1 minus stuff squared. Okay? Well, we have fractions on top of fractions, and then we have a squared over here. So let me handle the squared stuff first. Uh-huh. Square root. I found the derivative. Let's see here. What was this? What do we have here? Sine? So at the bottom, oh yeah, you're right. Yeah, you're right. It's supposed to go as is. Yeah, on the bottom, it's supposed to go as is. Yep, I wrote that wrong. So let me change this to square 2x 1/2 power. 2x 1/2 power. Yep, big difference there. So I got 1 minus, what's 1/2 power to the second power? Do I add or multiply the powers? Multiply the powers. When I multiply the powers, what do I get? 1. So that means 2x to the first power, which is just 2x. Okay. So again, here, it just depends on how far they want you to go. Wherever you're just trying to match an answer. If they have that as an answer, great, you're done. But chances are they won't because there's a fraction on top. So to get it so it doesn't have a fraction on top, we need to change the way it looks. Use some algebra here. Square root 1 over 2x. This is over 1. Well, when we're dividing fractions, we keep change flip. So keep the first one. Change to multiplication. Flip the second one. So on top, I get a 1. On bottom, I have two things that have squares, or square roots. So I can actually combine those to make this. 2x, 1 minus 2x. Because they both have square roots and I'm multiplying them. You can do distributive property. That's fine. You can do, so you would get 2x minus 4x squared, square root. That's okay. Or you can leave it like that. It's all about just matching what answer they have. So using algebra skills to do that. Being able to do that. Being able to, because I get this question a lot on tests. I'm done, but I don't see that answer. Are you sure this test is correct? I get that question a lot. Are you sure the test is not wrong? No, the test is right. You just have to use your algebra skills to do that, right? Algebra skills are one thing, like I said, one thing that are key to being successful in any math, really, but especially calc. Okay, all right, let's go to the second one. C. All right. So I have x times the inverse sine of x plus root 1 minus x squared. So it's got a lot of stuff going on here. So first thing is to look at it and what's going on. Is this a straightforward problem? What's going on here? What step? What's going on? What do you notice? Product rule, yeah, with what? Yeah, right here is product rule. I'm gonna have to use product rule right here. Good, that's one thing. What about the square roots? Well, what is square root? Is that part of, is that the stuff? Is that part of inverse sine? This over here. Is that what is that? lot of times people are like, oh, that's the stuff. No, that's just separate. So what we're going to do is we're going to find the derivative of the black stuff I underlined, and then we're going to find the derivative of the blue stuff I underlined. That's all we're going to do. What is the stuff on this problem? X. That's it. Okay. So the first thing we got to do is product rule for the black to underline the black stuff. Okay. Product rule says the first times the derivative of the second. Well, the first is just 1. Oh, the first is just x times the derivative of the second. Well, how do I find derivative of the second? You flip your paper over. That's what you do. You flip your paper over, unless you have it memorized already. And what is the derivative of inverse sine of x? Right there. The stuff, the inverse of the stuff, or the derivative of the stuff on top, square root 1 minus stuff squared. Okay. Well, the derivative of the stuff is just 1. Okay. Stuff was x, stuff squared is x squared. All right, plus the opposite. The derivative of the first one, which is 1, times the second. Okay. That's the first part. Now I got to find the derivative of the blue. Well, to find the derivative of the blue, I got to use chain rule. 1 minus x squared to the 1/2 power. Okay, so we move the power to the front, rewrite the power, or rewrite the stuff underneath the root, take away a power. I'm running over to the other side. Let me make this a little smaller, or just scoot it over. Okay. And then I have to multiply times the derivative of the inside, which is negative 2x. Calculus is done, but I'm telling you right now, that answer won't be there. That answer will not be one of your A, B, C, D, E options. Well, what can we do? Well, over here, I'm going to move the x, multiply to move the x over there. Plus, and then over here, I'm going to have a denominator of square root 1 minus x squared. I'm going to have a 2 down here and a negative 2x on top, but those will cancel out. So I have negative x over square root 1 minus x squared. But that answer you will not find A, B, C, D. Why not? What else could I do? Mm-hmm. Mm-hmm. This guy right here, and then the last guy, right? I can combine those two guys because they have common denominators. I don't have to do anything. They already have common denominators. Square root 1 minus x squared. So I add the top. When I add the tops, what happens? No, not 2. 0, yeah, they become 0 because this one has an x, this one has a negative x. Add them together, you get 0. So they end up canceling each other out. So the only thing that's left is this. That's it. Okay. All right. Let's see. Let's look at this guy. Actually, I want you to try this guy on your own. Try this guy on your own. See what you get. I'll give you a few minutes, and then we will go over. Okay. So for this guy, 2 times arc sine. 2 times. So it's not gonna. We're not gonna need product rule for this guy because 2 is just a coefficient. And then arc sine of this stuff here. Okay. Arc sine, not arc sine. Arc secant. Arc secant. So I go to my list, my sheet, and arc secant is uh, stuff, derivative of the stuff on top, and then it has some absolute value bars. Well, what do absolute value? Why do we include absolute value when we want what? What does absolute value do? Just positive, right? So the reason those are there is if your answer is negative, change it to positive. That's all it does. If your answer is already positive, if whatever you plug in there is already positive, then they don't matter. You're just saying if you do have negative stuff, make sure it's positive. That's all. Okay. All right. So derivative of the stuff, that's just 5. Okay. On bottom stuff, again, if the stuff is already positive, 5u, 5s. If the stuff is already positive, you don't need the absolute value bars because it's already positive. I mean, you can, it doesn't hurt, but if it's already positive, you don't need them. Okay? Root 5s squared minus 1. Okay? 5 on top. Again, 5s. Sometimes they will include those, sometimes they won't because it's already positive, so whatever. You don't technically need them, but if it's a multiple choice question and they have them, okay, it doesn't hurt anything. 5s squared is 25s squared minus 1. If they have the bars there, you can't factor. You can't factor. But if they don't have the bars here, so if they write it like this on a test, if they write it like this, then you could do this. You could do that. But I've seen them do both. I've seen them do both. I've seen them do that, and I've seen them say nope. So if they have the bars around them, then you can't factor them. But technically 5s is already positive. So yeah, so I've seen it both. So just know that that's why you can have both. The 2 in front, the 2 in front. Oh yeah, yeah, and then we got to multiply the 2. Yeah, I totally forgot about the 2. So we should have multiplied. Let me move this stuff over here. Totally forgot about that. Let's see. The 2 should have come and multiplied right here. Right? We should have had that, which multiplies the top to make it 10. So that should be a 10. And that should be a 2. Okay. Yep. So this isn't bad if you have these in front of you. If you have these in front of you, it's not that bad, but it's realizing the relationship between them. So when you're doing these, looking at the relationships between them. They're not bad because you just follow the roadmap. You just follow the map to see what you do. Okay? One other type of question. I didn't put it on here, but one other type of question that you might see. I put it as E. So one other type of question that you might see. Evaluate the limit and express your answer in simplest form. And then here it is here. Okay, I'll give you a second to write it down. So as you're writing it down, it should look very familiar to you. The bottom part should look very familiar to you. You've seen it before. You've seen the bottom part. You've seen the not the arc sine part, but the structure of it. You've seen that before. Where have we seen that before? When we were finding derivatives. Yeah, that's basically what this says. This guy right here, this outline. Anytime you see this outline here, no matter what's on the inside, but you see this setup, you see this guy here, you see H here, you see the minus there. This is pretty much saying find the derivative. That's all it's saying, find the derivative. Well, to find the derivative, you need a function. What's the function here? What are we trying to find derivative of? What are we trying to find derivative of? Here's the answer. I won't tell you because you know it. If you don't know it, you have resources. I think a few of you just wait for me to tell you the answer. I'm not going to tell you the answer. Not 0. What are we trying to find the derivative of? Yeah. What's the function we're trying to find the derivative of? This is the second part, right? I know what you're saying. This is all in your notes. That's where it comes from, right? In your notes, we highlighted that, hey, that's the original function. That second part there, everything after the subtraction on top is the original function. Okay. Arc sine of something. Arc sine of something. That is the original function. What is that 1/2 doing? Well, what they're trying to do is they're trying to get you to do this. They're trying to find, hey, find the derivative and then plug in 1/2. What do you get? That's what they're trying to say. So if arc sine is the original function, what is that going to be? Well, what's the first thing we need to do? What's the first thing we need to do to figure out? This is the question they're asking here. Because this is the original function. The 1/2 means once you find your derivative, plug it in. But what do I need to do? Don't even worry about that. Nope. Nope. Right here. We're focused over here. Yep. I just picked what I needed. What do I need to do? Find the derivative. That's the first thing I need to do. First thing I need to do is find the derivative. So find the derivative of arc sine. What's the derivative of arc sine? Well, derivative of the stuff on top, on the bottom, 1 minus stuff squared, square root. Derivative of the stuff is just 1. Square root 1 minus stuff squared. Okay. Now, to find this, I plug in 1/2 everywhere I have an x, just like you've always done. Okay. So I get a 1 on top, 1 minus 1/2 squared is just 1 over 4. 1 minus 1/4 is 3/4. Well, I can't have a square root on the bottom. Doesn't work. If I have a square root on the bottom, it doesn't work. So I have 1 divided by square root 3 over 4. Well, if the whole thing has a square root, we can change it to do this. Each have a square root. Well, the square root of 4 is just 2. Keep, change, flip. Keep, change, flip. So I get 2 over the square root of 3. Well, the square root of 3 is still on the bottom. I can't have that. So I have 2 square root 3. How do I get rid of the square root on the bottom? Yeah, multiply by the thing that's causing the issue. The thing that's causing the issue is the square root. So 2 times the square root of 3 over 3. There you go. Done. Okay, all right. I'm going to give you one like that. Here we go. Let me try this one. Here's another one. So we'll call this letter F. Okay, letter F. Okay, so again, this is the setup for derivative. Find the derivative. So what they want us to do is to find the derivative of this guy, because that's the original. And then once you do that, take this guy and plug it in. Okay, so we got to find the derivative of inverse sine or arc sine. So it's going to be 1 over 1 minus stuff squared. Okay. All right, now plug it in. Now plug in what they want me to plug in, which is 1/3. So I get 1 over 1 minus 1/3 squared. 1 minus 1/9. Okay, 1 minus 1/9 is 8/9. So I have 1 over square root 8 over 9. Another way of writing that is the square root of 8 over the square root of 9. The reason I'm writing that is because the square root of 9 is actually a number. It's 3. Okay. So I have a square root on the bottom. So I can't have a square root on the bottom. So to fix that, let me move this a little bit up first. To fix that, I'm going to rewrite it. 1 divided by square root of 8 over 3. Keep, change, flip. 1 times 3 over square root of 8, which is 3 over square root of 8. But it still has a square root on the bottom. So I got to rationalize it. So to rationalize it, I multiply by the square root on the bottom, which when I do that is going to get rid of the square root on the bottom. And you're done. Okay. All right, let me show you one that's very similar, but a little different. Just so you can see, because you might see it like this. There we go. What's the difference between this one and the one you just saw? Or the last two you just saw, besides it says tangent. I know it says tangent, and the last one said sine, and the one before that said, the last two said sine, but besides the tangent part, what's the difference between this one and the one you just saw, you've just seen?
There's x's instead of the fraction.
Yeah, there's no numbers in there, right? Just x. How does that change what we do? Yeah, that in here, let me see if I can get a highlighter. In here, there's no number, right? It's just an x. That's not what I wanted. Okay. How does that change what we do? What we did on the last two problems? Mhm.
You're not plugging in a number anyway, so I guess the only step you have to do now, I guess, find the square root of 1.
That's it. Yeah, there's nothing to plug in. If there's nothing to plug in, you don't have to do that. So all it's asking you to do is find the derivative of arctangent of x. That's all it's asking you to do. You don't have to plug in a number afterwards. Okay, it's the same thing, just with no plugging in. If it has a number there, you plug it in after you find the derivative. If not, you don't have to. Okay, that's the only difference between those. Okay.